Meantime, with air travel incidents and crashes seemingly growing more common all around the world, engineers have designed a new AI-powered safety system to prevent future tragedies. Photos produced by Project Earth show airplanes with what looks like airbags deploying on the outside of the plane to cushion a fall. On the website, they describe the design, explaining that upon falling to a certain altitude, the plane would deploy smart airbags, impact absorbing fluids, and reverse thrust mid-air, turning fatal crashes into survivable landings. According to the engineers, AI sensors could detect when a crash is about to happen and deploy those airbags, in theory stopping a deadly crash, even from high speeds and heights. And with that recent Air India crash, remember this back in June, only one person survived. These engineers are submitting these plans as part of a contest to create alternative methods of safety. So I'd like to welcome in aviation safety and NAS expert, Philip Mann. Philip, it's great to see you. So
Welcome.
we're seeing these renderings with these planes, essentially with airbags deploying around them. What is your reaction to this idea? Do you think this is a concept that could actually work?
I'm willing to give a little bit of grace to the diagrams because they're very clearly just AI generated. Somebody put in a prompt that said put airbags on an airplane. But I think that these are a little bit of too much being in love with AI and kind of missing what the fundamental problem is. Because in general aviation aircraft, in small aircraft, we already have things like parachutes, and we already have things like passenger airbags. And I think it's kind of a mistake for these folks to jump clear to an AI thing and essentially, potentially taking the pilot entirely out of the loop when they haven't yet scaled up existing systems that possibly could be brought to bear in this thing. Because one of the challenges we have with, and we've talked about this before, one of the challenges we have with aviation is it's very unforgiving. And there's not going to be an opportunity to beta test this stuff. There's not going to be an opportunity to put it on a plane and then see if maybe it works and then patch it and update it later. So jumping clear to an AI implementation and a very exotic form of arresting system or safety system, especially something like what's on the screen now that would radically change the aerodynamics of the airplane within a couple of seconds. I think that's maybe looking 50 or 100 years into the future, but there's much more near-term engineering things that have been proven at a smaller scale that could be brought up into something that might work in commercial aviation.
All right, so Phil, talk a little bit more about that. I mean, has anything like this ever been tried before, or what are some of these other things that could maybe be tried?
Yeah, in smaller airplanes, in Cirrus airplanes, and a lot of smaller general aviation airplanes, we're talking like what people think about a private airplane. There are frame attached ballistic parachutes that when the pilot decides or when a passenger decides that it needs to do, they pull a handle and it shoots a parachute in the air and it lowers the airplane down to the ground relatively safely. There's also systems that have airbags built into the harnesses in these general aviation aircraft. Now these have only been approved and only been certified for these smaller airplanes, but there's not a big reason I can think of why they wouldn't at least try to scale these up before they went to something truly exotic, because they are designed for exactly the kind of case that they're talking about, where there's a crash is imminent. Importantly, the air crew knows there's a crash imminent and they can no longer control the plane, in which case you need to implement some kind of a technological arresting system. One of the things I'm kind of concerned with this AI implementation is I can imagine, like with the Air India flight, or even if you think about the Sully Sullenberger crash in the Hudson, that, well, what if the AI decides that this plane is unrecoverable and it initiates a system and turns something that would be a landing in the water or potentially a landing in the field into a toppling beach ball of airplane and people going down the road for a while. This diagram here is a great example of that. This would just turn an airplane into a beach ball. It's just going to fly down. It's just going to roll down the mountainside or wherever it lands. But there's lots of the things with aviation is everything that gets into an actual operating aircraft has to be tested. It has to work, and it has to work every single time. And that's one of the challenges with implementing AI, because even the closest kind of AI appearing systems, like Garmin has a thing called, they have this automatic landing system that is literally a pilot or a passenger pushes a button and then the plane takes care of everything and lands it at the ground. That entire thing is done with algorithms. There's no AI in it at all. It's all algorithms. It's all known places, known systems, known situations, and it gets to the ground and even talks to air traffic on behalf of the aircraft. And those kind of things work. And that's part of the challenge, is that they have to work every time. We have to know exactly how and when and why they make decisions with any number or combination of inputs. And that's something that AI just is not good at right now. And as complex and complicated as air transportation is,
right,
it's difficult for me to imagine, even in some of these labs that are working on AI stuff, that they're going to be able to test every conceivable combination of system failures and every conceivable combination of passenger loads and wind and everything else, and be able to document each and every time how the system's going to respond. Because unfortunately, it's a great thing to say maybe we can put the second brain of AI into the cockpit and have it maybe help the pilots out. It's a stretch to say we're going to have this thing actually activate safety equipment. It's one thing to say it's going to advise the pilot and maybe flash a light up that says, hey, you might want to think about this safety system. It's an entirely different thing to say, well, we're going to build this radically aerodynamic transforming system, and then we're going to put it in the control of something that we're not sure how it works.
right. And I do want to ask you also, Philip, about the story that we told viewers about right before this. This new report from the Wall Street Journal on these toxic fumes that are being, or allegedly being, released into the cockpit, into the cabins. What is your reaction?
My reaction to that is it sounds very much like a maintenance issue. It sounds like maybe there's a seal or something that's not where it needs to be. And it might be something that needs to be changed by some kind of an engineering update to the aircraft, because this seems to be a very rare sort of thing that would happen only when the right conditions show up. Obviously, if there were toxic fumes getting into every airplane in the fleet, this would be all over the place right now. And it just seems like something that the airlines and the aircraft manufacturers need to look at, see if it's happening, or actually if it could happen, and then implement whatever maintenance or engineering change needs to take place to make sure that, to take that little bit of a could happen and make it a can't happen.
Yeah. And just really quickly, I mean, at the end of that, we said that Delta Airlines is saying, listen, air travel does remain the safest form of travel. But as we know, Philip, I mean, when something goes wrong, it can be massively tragic. Do you think that will kind of just always be the case with this industry? It is overall extremely safe, but yet when something goes wrong, it can go really wrong.
Yeah, and I think scaling up some of those technologies, like I talked about taking that parachute that's in a small plane and figuring out a way to scale that up to a larger plane, and basically allowing some other way to get to the ground other than falling. Those are going to be ways that we start implementing it. There's designs coming out that are creating aircraft that glide better, that fly maybe a little bit differently, that allow a little bit more of a margin of failure, so they don't need every single engine, they don't need every single thing working, so they can fly a little bit longer, a little bit better, with maybe a little bit of breakdown in the system. And I think the aviation itself has always got that in mind. We always want to get people from point A to point B safely. We want to get products and goods and all that from point A to point B safely. And it's just as safe as it is just unfortunate that an airplane that runs into a problem on takeoff or landing just doesn't, the forces and physics and stuff involved just creates a problem. So right now we're dealing with a problem of physics, of figuring out how to make a crash less lethal. We've already figured out how to make them exceedingly rare. Right. Now we just need to figure out how to make them less lethal and make them more survivable, if you prefer. And that's the puzzle right now, and it's going to be met in some way that is repeatable and safe and reliable, and importantly will work every single time, not be just handed off to a computer to decide, oof, okay, we're going to turn your airplane into a cannoli, and now, yeah.
All right, aviation expert Philip Mann, turn your aircraft into cannoli. That's a good visual there. All right, Philip, thank you.